Thanks for showing up and saving my sorry ass. I wanted to have a presentation on 3D and how we do it here at Haaga-Helia because quite a lot of people have been asking me about it, and currently there are 191 people on the Blender course that starts today. Pretty heavy, but it should be okay. I would like everybody to join the Haaga-Helia 3D group on Facebook. It doesn't cost you anything, but there's something going on every day, and also we are going to start live meetings for the 3D club. So even now there's a poll for people so that they can vote what they want to do in the club. But this is the topic, 3D printing, design, printing and Haaga-Helia, and the subtopic is why should you care about 3D? First a few words about me, because I've heard it said on the corridors that I'm some sort of an engineer. Actually, I'm an honorary engineer because in one of my workplaces I was told that I must be an engineer because I like Excel so much. But I'm not an engineer, I'm an English major, and if I can learn 3D, basically anybody can learn 3D. During my 30 years in the business, I've done a lot of different things, but none of them have been as fun as 3D. I have to say that, with the possible exception of doing games. That was also fun. But yeah, it's a 5-part presentation, 3D today and how to make some. A case example on the workflow, 3D printing our way, 3D printing their way, and Haaga-Helia and 3D. It's going to take about an hour or so, and then we can have a questions and answers type of session at the end. So, 3D today. This is from Big Buck Bunny, courtesy of Blender.org, where you can see the entire movie. And if you want to go there and lift all the pictures and make your own movie, it's fully legal. It's open source. It's a funny movie. Go see it. Because 3D is everywhere, we cannot open the web or a browser today without seeing something that has been passed through a 3D system somehow. You can name any field and somebody is doing something in that field with 3D. It's advertising, entertainment, education, construction, whatever you name, somebody's doing something with 3D. But and also the availability of 3D images is growing, and the availability of software with which you can make 3D is growing. So to make something you need a 3D environment, and if you want to go with the Autodesk products, currently you can get them for free for the duration of your studies through Haaga-Helia. But after that, it's going to cost you 1,600 euros per seat per year. Of course, if you are working someplace, it's not a big deal, but for your personal use, it's going to be pretty heavy. The same goes for Maya, Cinema 4D, and Lightwave. Cinema 4D, by the way, is used mostly in media and advertising because it's very fast. It's very easy to create all kinds of 3D things there. So the basic problem there is that they all cost money, unless you happen to have a student license. Well, why pay when you don't have to? Because Blender is free, it's open source, and it's just as powerful as all the others. You can go there now at Blender.org, get it downloaded, and start right away. There's hundreds of thousands of people in Blender Space, which is the virtual environment where Blender people go. They're called Blender heads. And it's a fun place compared to Meet Space, which is where we now are. It used to be a competitive package for Autodesk, but then they found that they really can't compete. Autodesk is too big. So they went to the web and asked for some money. They got $100,000 in 7 days, and then they gave the software to Blender organization, or the foundation actually. And that's why we have a foundation that runs the development. And there's a new version out almost once every month. 2.78 is the current version. and every time something comes out, the next version is always cooler than the previous one. But you have to keep updating the software so that you stay on top of the software. So it's slightly tedious in that sense. So the key features are 3D modeling, of course, with materials. There's an animation engine. There is a game engine. There's a physics engine. There are 3 different render engines. One is Blender internal, one is Cycles. This is made with Cycles. The camera is virtual. The bookcase is real. There's a video editor. I used to run Pinnacle Studio, but I don't anymore because it used to crash. Blender never crashes. And then there's a compositing system, which means that I can do compositing, which means I can place virtual objects in front of real objects and then render the image, and it looks like everything is like a real object. And of course, since 2.59, we have had export to 3D printers, which is not bad at all. Yep, come on. It's better to stay on this side because the screen is here. So the foundation develops the software. There's a core bunch of people doing the development, and then there's hundreds of people who donate their time to the organization and develop some feature, and then they are joined to the trunk and released in the next bigger version always. There's lots of resources. There's a definitive manual and Blender projects. These are the movies that are now out. This is the first one. There's a second one. This is the third one, and that's the latest one. Tears of Steel, and they are now working on a thing called the Cosmos Laundromat. The first 10 minutes is online, so it is very promising as well. So what do you get when you download Blender? You get this. I said it's free. I didn't say it's easy. But then again, I have to say that 3D is not hard. 3D is tedious. 3D is hard work. It's all about understanding the very basics first and then adding tiny bits one at a time, all the time. And well, if you are faced with something like this, where you have a cube and you have a lamp and you have a camera and you have a 3D cursor, and then you have all of these buttons and thingies, it is quite overwhelming. But in the Blender course, the first 4 packages are basically focusing on this first view so that you understand what's going on. There's 7 different editors on the screen at the moment there. And you can change any of those editors into 17 other types of editors. So you can really make a mess out of it. It's very easy. I've done it many times. But once you get going, it's really interesting because this is all that you have to understand. When you understand this slide, everything else is just hard work. When you do 3D, you only have vertices. A vertex is a point in space. It doesn't have any dimensions. It only has a location in all the 3 axes, right? When you connect 2 vertices, you get an edge. The edge has length, but it doesn't have any other dimensions. It has direction too, because of the location of the vertices in the 3-dimensional space. It can point anywhere. And when you connect 3 vertices together, you get a triangle, and then you can have a face in that triangle. That's the smallest face you can have. One that has 3 vertices on it. But in a cube, you have 8 vertices connecting 12 edges and building 6 faces. Now, of course, a mesh like this is not very useful unless you are modeling, let's say, a pair of dice. You're pretty much done already. All you have to do is to add the material. But human heads are usually modeled starting from a cube. It's better than a sphere, because the human head is closer to a cube than a sphere, really. You have too many vertices if you start with a sphere. So they start with with a cube, they slice it up into halves, they lose the other half, and then they use a thing called subdivision surface 2 times, and that's when you have a nice start for your head. But you can wind up with 500,000 vertices if you are not careful. It happened to me a couple of times. I made a Spitfire once, and then I went and I pressed the apply button in one of the tools, and that gave me 500,000 vertices. And after that, I was unable to edit it any further because there's just too many bloody vertices. So the less vertices you have, the better you are off. Trust me. Now, how to make some 3D? Well, of course, if you want to go out and do something like this, which is Sintel and her pet dragon, you are looking at a very, very heavy project. But it's by no means impossible. You can download the models if you want to. You can download the meshes and start working on this if you want to, because it's all open source. But I'll show you a video that will do show you the cube, delete almost everything, just one vertex is going to be left, and then it gives you the rest of the cube back from there. Because you can do this very easy. So, this is the Blender workspace. When you open Blender, you always get this. There's a few standard items in it. Why can't I see that? No, it should show. Okay. Let's go back and start from here. Okay. Now it works. So you have a lamp, you have a camera, and you have a basic cube mesh, and you also have a grid that you cannot touch, but it's there for your placement of things, for example. When you press the scroll button, you can orbit, you can pan, you can move the view, and then you can go into and select this object by right-clicking on it and then go into edit mode. And now in edit mode, you can touch any of the vertices, or you can touch any of the edges, and you can delete any of the edges or the faces, whatever you want to do. So we're going to go back into the vertex mode and select one out of the 8 vertices and delete the others. So what you have now is one single point in space that doesn't have anything to it except the location where it is. And now we will press the E key and extrude. Essentially it makes a copy of that one vertex, and you get 2 vertices, and then you have an edge. Then you can select the edge and extrude along the other axis, and hey presto, you have 4 vertices and you have a face. And then you can select the face and extrude up, and you have the same cube that you started with. Just 3 moves. And this is the very basic operation in Blender. All you do is touch the vertices, arrange the vertices in the way you want to have them, move them anywhere you want to have them, and there's nothing to it really. So the process is always the same. First you identify what you want to make, then you think about the basic shapes that you want to use. There's about 20-25 basic shapes that you can use. The cube, the sphere, actually 2 different spheres, a cone, a circle, a plane, all that kind of stuff. And after that you make the mesh, and then you add materials, and then you add textures, and then you add a scene, lights, whatever you want to have, and then you render the image of the movie. So I'll take you through this case example. This is an outboard engine. If somebody has seen this already, they can take a nap, but please don't snore too hard. So I wanted to see if I can make that engine. And it's pretty complex as you look at it, but then when you start really looking into it, it is not that complex. So first you have to find some good reference images that you can place on the background in Blender, and then model on the top of the pictures. Actually, it's very nice. So the basic shapes in here are actually the best basic shape is this part here. This is the crankcase or the gearbox. There's half a sphere in here, and the half a sphere is continued as a cylinder. So I took a sphere, I rotated it 90 degrees, and I deleted the other half. And as you saw with the extrusion, the E key, if you have a circle and you extrude, you get a cylinder. So half a dome here, extruded out as a cylinder. And it looks like this. This is the first part. This is the first extrusion. Then I selected some faces down here and extruded down. And then I scaled this end here. And now it looks exactly like the fin on the engine. Then I took some faces up here and extruded up. Then extrude sideways, up and inwards to get the cavitation plate. The first part is actually something like 3 minutes. And that's the lower half of the engine, all done. All you have to do is to look at the picture and extrude and scale and extrude and scale and extrude and scale. And this is the engine when it's done without any materials. So it looks pretty boring, but it looks exactly like the image. It's been modeled on top of the image, and it is a very close match to the images that I had. So let's look at the materials. Most of the engine is actually semi-glossy black. Well, in Blender you can have colors that are glossy, you can have colors that are diffuse or matte, and if you made it fully glossy black, it would not show at all because it would reflect all the light that it gets. And if you make it fully diffuse black, it won't show at all because it takes in all the light that it gets and it disappears. So this is about 70% glossy and 30% matte. Then there's a couple of decals. One is here, one is there, and one is here. And those have to be made by hand. So I went to the web and I found this image, and I called the firm that makes those. And I said, can I have that in a high resolution picture? And they asked me why. And I said, I'm making a 3D model of the engine. And they said, we'll call you back. They never did. So I took the picture and I expanded it to 2048. And then I drew on top of that. I found a font that was pretty close to the original. And then I used GIMP to make it like nice. Because when I used these decals, if I used that, you could see pixelation all over the place, because everything would have to be stretched to fit the image, fit the mesh. But with the materials, this becomes this. So you see we're pretty close to where we wanted to go. Sorry about that. So all you have to do is to identify the place where the decals go. 1, 2, 3, 4, 5 in here, and then just place the decals there, and everything else is just semi-glossy black. Then you have semi-glossy steel and semi-glossy aluminum up here, and it's getting pretty close to what I wanted to have. But with the big picture, there's no pixelation. You can actually zoom in as close as you want to. The faceplate is made in Excel, because Excel is very good for making grids of things. And in Blender you can tell that if something is black, then make it look like it's a few millimeters in, and if it's white, pull it out a little. And that's why you could do that. This is actually a flat plane, but it has this bump map on it, and that gives it the 3D. So you can fake as much as you possibly can. Nobody's going to come and check if this is watertight. It isn't watertight, but it doesn't have to be. It looks nice. That's the point in 3D. So I couldn't find this text in here, but I made my own. And if you go to Google and you search for Blinkenlichts, you will see that it's a classic text that was usually pasted on big IBM machines in the 1950s. And I just converted it a little so that it says, das Outboard-Engine ist nicht für Gefingerpocken und Mittengrappen, ist easy schnappen das Spingenwerk. Now, why did I do that? Just because somebody might zoom in and want to see the text. So I wanted there to be text, not just something. Because the devil always lives in the details. So here's the first image, and it's not entirely believable, is it? No, that's a fake. Because, well, of course, it's Lake Tahoe in the background, and it's my modeled, 3D modeled engine. So it would be very hard to make this believable. You would have to adjust the lighting a million ways to get it going. And also, somebody is basically holding the engine like this out of the picture, so it's not very nice. But by this time, I was so hungry for more that I wanted to add a scene. And in the scene, I wanted to have a boat and a lake and a pier and whatever I want to have. So this time, I didn't want to make the boat into a very, very, detailed, high-tech type of thingy. I wanted to have a boat that looks like a boat. So I found a boat on the web, and then I made a boat that looks enough, close enough to the boat, right? Because once you add the engine to this boat and you add some things, you get this. Now, the water is actually a plane, okay? But it has been subdivided about 4 times, so there's about 1,000 vertices on that. And then we have a modifier called the ocean modifier, where you can say that the wind comes from that direction at 4 meters per second. There are no white caps, but it has been going on for a while, so you have the swells, right? So you just let the animation run until it looks nice, and then you grab the picture. Also, you need a modifier on the boat called shrink wrap, elmu, because the water went right through the boat. Of course, the meshes don't know about each other unless you explicitly tell them about the other meshes in the scene. So the water goes through the boat unless you add shrink wrap to the boat to keep the water out. Okay, then you fine-tune the setting. You make the water skis, you make the fender, you make the car tires for these thingies. You add these iron rings for the ropes, whatever. Then you make the Acme Cola cans. I didn't want to make it Coke because I don't want to get sued. So it's Acme Ski and Acme Cola. And the boat is Speedster 19. And I showed this picture to a friend of mine from my phone, and he's very big into boats. And he was like, I don't know that type. Is that a Marino? I said, no, it's not really a Marino. But yeah, there's no end to what you can do. Once you get to the scene place, you can just keep going. So this is the final image I wanted to render, because this one has the sun over there. And you can actually tell Blender how your mesh is located, where on Earth it's located, and what time it is. And then it will calculate the location of the sun. So if you wanted to have this in a Florida setting, you could actually easily make it by setting the sun using the coordinate system. Okay, so this is the final render I made, but it's not the end of the story. Because once you have your mesh, nothing is keeping you from animating it. So I have added 3 particle emitters here. They are throwing small spheres that are slightly blue and transparent. So they look a lot like the water jets that you get if you have a boat. Now, of course, because this is a test, it's like a proof of concept type of thing, they are going all over the place. But if I placed these emitters close to the engine and I had the boat in here, I could actually pretty easily simulate how it would look if the boat came from the left and passed you over to the right, throwing these small cubes. So yeah, now it's animated. If you wanted to make a game out of this somehow, well, the mesh is there. You can start doing whatever you want to have it. So this is the fun part of Blender. You're never out of things to do. Oh, by the way, if anybody has any questions anywhere, just pop up the hand and ask me. Because now we are going to go into 3D printing as we do it. Part 3. This is from Elephant's Dream. It's actually a nice movie as well. Should go and see it as well. So, 3D printing is also known as additive manufacturing, and the difference between the old way and the new way is that you had to guess that this piece of rock has Julius Caesar in it. And then you would have to spend 6 years with the hammer to get this guy out of the rock. Well, I don't have 6 years, and I most definitely don't want to do that. So what I do is I print things. I only add material where I need material. So I'm trying to make it sound as easy as 1, 2, 3 because it is actually as easy as 1, 2, 3. Once you understand how to make meshes, once you understand modeling, the moving from modeling to printing is actually a no-brainer, because all you have to do is to create your meshes in a certain way so that they are not too big and they don't have angles that are in excess of 60 degrees from the vertical, or actually 45 degrees from the vertical, because here you need supports. And here you cannot fake anymore. Your meshes have to be watertight. If they're not, Blender will tell you and you'll spend hours finding the fault. But yes, once you have the object, you can export to STL file format and then check the file for holes, and then fire up the printer and use the printer software to actually do the printing. And therefore, the design can be done in any software. They all export STL. All you have to do is to consider the size. My printers are small. They're 15 by 15 by 14 centimeters, and I have one that does 15 times 23 centimeters. But if things go right, I will have 8 printers by the end of the year, and I will have 24 seats on the printing course, if things go right. If not, I will only have 15 seats. So it's going to be a large competition to see who gets in. The STL file, Blender files don't print. You have to export from Blender into STL. And STLs are basically triangles on triangles on triangles. If you think about 3D printing as a whole, you are doing 2D printing many, many times in the same place. And that's how you get the third layer, the third dimension. So if you were doing a hollow cylinder, you would be printing those triangles and then moving the print head 0.1 or 0.2 millimeters and printing again in the same place, and then moving the print head up and then printing again. That's why it takes so long. If you look at the chess table that we have over there, the table itself takes about 16 hours to print, and the two sets of these pieces is also 16 hours. So it's 32 hours to make one table. This is not for those who are in a hurry, really. So the printing, this is the cool part. Let's say you make something that looks nice, and it prints nice on our small printers. That same STL file can be printed into any material available on the planet without any further modification, using any other printer. So Kalevala Koru enables you to send them the STL file of jewelry, for example. They will print you the piece of jewelry you want to have and charge you the price of the material plus 20%. I've seen some really cool, unique jewelry. So there's also a thing called G-code. Now, G-code is the control code of the printer. The STL is finally turned into G-code, and the G-code then is actually guiding the printer. Now, that is actually something that cannot be exported from one machine to another. So you have to take the STL file, not go the final mile before you do that. But after that, yes, it's just a question of hitting print. Here's some different techniques that you can use. As you can see, extrusion using thermoplastics, ABS and PLA. That's what we do here. That's available. Then this is somewhat unavailable because this is 500,000 plus, and they turned me down when I asked for one. They said that no. Stingy people. We could have this. I've seen this in Madrid in one of our in one of our cooperation schools, they actually have these plaster-based things. They're pretty neat. And then we have the light polymerized stereolithography, about 5,000, but the resin that they use is highly toxic, and I don't want to buy one of those, merely because I don't want to get people killed if they happen to inhale the fumes. Speaking of death, by the way, PLA is biodegradable. So if you happen to get killed and they make you into ashes, you could actually print your own urn for the ashes and bury the urn, because in 2 years it will fade away. There's a business idea for you. So as you can see, there's lots of things that you can use, but that's because there's lots of materials and there's lots of things that you have to do. If you're printing something that goes inside somebody's head, well, you don't do it with our printers. But again, if you wanted to do something that you then printed in some high-end machine, all you have to do is to use Blender, make the mesh, export into STL, and test with our printers that it works. Simple as that. This is our main machine, the mini factory. We have 3, Huey, Dewey, and Louie, and then we have Donald, which is a different model. So it cannot really get any simpler than this. You have the materials, and then they are fed in here, and you have the hot head here, the print head, and then you have, this is the Y direction, this is the X direction, and this is the Z direction. So the printer will extrude the material, and the table will move, and then it makes the whatever you want to print, and then the print head goes up, and it prints again, and it goes up, and it prints again. Simple as that. So if I wanted to make a Blender, see, this is the Blender logo. If I wanted to make a keychain from the Blender logo, I would have to find out what is the basic shape from where to start. The basic thing to start is a sphere, which you cut in here, then extrude sideways, up, sideways, down. And then you add a face at the bottom. Then this is actually the hardest thing to make, the hole. Holes are harder to make than things that are real. So yeah, this is how it looks in Blender when it's done. And then I can hit F12 and Cycles will give me this. This is the render. And then I take it to the burning software, which is Repetier Host. You place the thing in here, then you can scale it, you can rotate it, you can move it, and you can check that it's manifold. This manifold here means watertight. And you can check it here. And then you can use the slicer to give you the sliced version, the G code if you wish, and then check it out that all of these are in place. And then all you have to do is to hit, this is the G code by the way, G21 sets units to millimeters. If you were really high, if you were really hard code type of thing, you would actually be able to write the G code and print something out of it. But it would be very hard because even this thing here is going to take 25 minutes to do, and it's something like 18,000 movements on the table and on the print head. So you would be writing 18,000 lines of code by hand. It would be nice to see if somebody did it. And then you hit print and hey presto, here we go. First we heat the print bed to about 110 degrees if we are using ABS. Then we heat the print nozzle to 230, 235, 245. And then it goes on. The first thing it does is it initiates the thing with the brim. And the brim is there merely to make sure that it sticks to the table. And then it makes the first solid layers. It makes 3 solid layers first, and then it starts to use infill. And infill is just a way of saving material. Instead of printing solid blocks, it will use 20%. It will just create a network of lines inside the piece that is 20% of the weight of the actual material that you would have if it was solid. But even if you print something like this, yeah, I know it's like nothing else will happen during the movie. Even if you printed a solid piece or you print a 20% piece, you cannot break it in your hands if it's a 20% piece. It's so tough. Yes? Yes. It actually has an Arduino in the back. This is actually the project of a guy called Janne Pihlajaniemi at the Seinäjoki Polytechnic. He made this as his thesis. And then he walked across the street to the government office and said, I have one of these, would you like to give me a government grant so I can start a firm? And they wrote the check right away. And now he's selling about 1,000 a year. And they have a new machine out, it's called the, what was it called? No, well, anyway, it's big. It's like 30 by 30 by 40. Of course, the print time is about 60 hours, but who cares? So yeah, that's what happens. And this is the same thing, but in real time. So you understand why I made a time lapse. It's actually not the same piece. This is a headphone container or headphone box. But you get the point how it works. It moves the table and it adds molten ABS to the thing. This is actually quite nice in the sense that this one has this is like the a bolt, and then on the lid you have a screw, so you can screw it on, and it's very nice. Yes. No, there's no limitation. So you could, yes. It could be, yes. And also this is known as the XY table. There's also the Z table, where the table moves down and the print head moves on the X and the Y. The other machine that I have, the Donald, is actually a Z machine. So, but there. This is not for those in a hurry, that's for sure. Any questions on printing as how we do it? Because now we go on printing how they do it. Okay, this is from Tears of Steel, by the way. It's really a nice science fiction movie. It's only about 15 minutes long, but it's really nice. This is why I actually wanted you guys in here. Because Forbes magazine in 2013, see the yellow bars? In 2013 they thought that we would have 3 million, 4 million, 5 plus 6 plus 7 plus 9 billion per year. Only 1 year later, they came out with the blue bars, where we have 20 plus instead of 9 plus billion per year. And this is an estimate. So the last estimate that I have heard for 2020 is actually in the region of 40 billion by far already. So this is one of those industries where it's going like, it's almost like the hockey stick thingy that they are using also for the climate change and other stuff like that. So let's look at who's in the business. Well, GE and Boeing, Ford, Nike, Hasbro, and then a bunch of startups like Hewlett-Packard, Amazon, Pratt & Whitney. These are serious players, folks. Well, just look at what Boeing is doing. 20,000 different 3D printed parts for 10 types of airplanes. And all of these parts are man-rated. Man-rated means that they can be installed in a plane that is actually flown by people or has people on it when it flies. They're not drones like Raptors. They're actual planes. What are they doing? Of course, prototyping, sure. Product development, yeah. Innovation, 10% of all the effort, or 11% of all the effort that goes into 3D is in innovation to make things that are impossible using traditional methods. Because with 3D printing, you can actually make pieces that you cannot make by milling or drilling a piece of metal. You can make things that cannot be made in any other way. Also, improved or expanded product line. See this 8% customized products. I'll give you just one example. It's from Hasbro, who make kids' toys. They are going to come out with games where you have thingies, the pieces that you play with. And then when you get to a certain level in the game, you will be sent an STL file. And you can print the new character for the game, and you will have superpowers in that game. And you can send it as a gift to your friend if they have a birthday party. You can send the STL to them, and they can print their own. And next time you play, you'll have superpowers. So this is just one example of what you can do with these things. So the industries then. Yes? I'll show you in a moment. There's one down there. So look at the industry sectors. Automotive and industrial manufacturing, cool. Aerospace, yeah. Pharma, healthcare, sure. Retail and sports. So what's out of these? Not much. 3D can be used in all of these sectors, which covers probably 95% of all industrial production. So this is their printer, and that's ours. So, well, so what if they can do metal and they can do this and that, and we can print cool stuff like it's like much cheaper than theirs and whatever. But like, you get the point. I would love to have one of those. This is actually it's like a wheel for a car. It's too bad. Anyway, this is automotive. First, there's an engine block. So the traditional method of making engine blocks is that you take a piece of metal and then you drill 5, 6 times from all kinds of directions, and then you come up with the engine block. That's all well nice. But when you print it, you can actually make channels inside the block when you print that you cannot drill because you cannot reach something that's behind another curve. So even this is one example of things that can be printed, and they are better than the ones that you make by milling. Then you have this, the central column, and this entire car has been 3D printed. So yeah. Then we have aerospace. Check this out. This is a piece for you know, the flaps on a plane when it goes down. When it doesn't go down, it comes down. When it comes down, they put out the flaps, and this is a hinge for a flap. And this hinge here weighs 2 kilos, and this hinge weighs about 300 grams. So if you can get that kind of weight saving for any part in the plane that you need, it's going to be, you know, tons lighter than the one that you can make with traditional methods. And it's going to be that much cheaper to fly. 1%, this is a fuel nozzle. It's all printed in one piece. So this fuel nozzle alone saves 1% of the fuel costs on a certain type of General Electric jet engine. And since they fly almost like 24/7, it's going to save a lot of fuel when they install of these everywhere. And if you were looked, this is another good example of the fuel flow, because you can have channels inside here that cannot be milled. Inside there, you have channels that have optimized the fuel flow, and that's why it saves the 1%. And that's why the whole thing works better. This is a 3D printed jet engine that I can actually make like 33,000 revolutions per minute. And you can put this on a drone and fly it off the ground. And it's all 3D printed. All you have to do is to dust it off and assemble it. Then we have the pharma or healthcare. There's a heart. There's a lower jaw. And this guy seems to have lost control of his head, and they are going to give him some mesh that will then enable him to have a full head again. It's pretty nice. And some of these are actually printed with materials that will then allow bone to grow on it, and then when the bone is there, it will degrade away. So he will be left with just bone in the head, but it will be exactly the same as the other half of the head. They are also printing bodies for students because not enough people leave their bodies to science, so they are 3D printing bodies for students to operate on. Then we have retail. I mentioned jewelry. This is a fully custom foot insole. You know, nobody has a similar foot to the other guy, so if you went there and you stood on this 3D scanner, they'll be able to print insoles that are exactly right for your feet. And of course, stuff like this is a no-brainer to make. Even we can do this. That's no big deal. So people have asked me, isn't this going to lead into a situation where everybody is printing stuff all the time and then it's not going to be very ecological? But I've always told them that I've never printed anything I didn't need. But I've printed many things that I couldn't buy. So it's not going to be printing for waste, it's going to be printing exactly for the need. And that's why it's going to be ecological. This is a 3D printed tennis racket, and then these are the footwear, and then we have these which also are, first you let them scan your head and then they print you the frame. And in Kuopio they have managed to print even the opticals. Pretty cool. So I am not going to go into construction or augmented reality or virtual reality because we don't have time. But one last word on manufacturing. Hewlett-Packard is coming out with a new type of printer. It's about 100 times faster than our printers, which means that the print time is going to be, like what I've done, 45 minutes is going to be like 2 minutes. So with that thing, if you have a manufacturing run that is less than 55,000 pieces, it's actually cheaper to print than manufacture by traditional methods. And half of the printer is already printed. So 55,000 pieces is already a huge manufacturing run. But if you don't have to make all the dies that you use for the traditional methods of manufacturing, you're going to save a lot of money. Okay, now, why do we have to care? There's a couple of slides on why we have to care. First of all, check this out. 70% of companies is doing something. Only 1 in 3 is not doing anything at the moment. That means you stand a 2 out of 3 chance to be asked the question, so what do you understand about 3D when you go for your job interview? If you have to say that I don't have a clue, unless instead of saying, well, I took the course, I know the basics, I can make some simple meshes, I know how to print them, I can easily grab the rest, you stand a chance of beating the other guys who say that they don't really care. This is the other part. This is them, 500,000 plus, whatever. This is us, 1,500s, hobbyists. Our capabilities are going up, as you can see. The cost is going up slightly. Their cost is coming down. And we have a nice area here where you can actually start making things and then go to the high-end market for the mass production. You don't have to buy a 500,000 thingy, but you can make things with the low-end things and then go upscale the operation when you start selling what you have. Okay, so this is big buck money as it is seen in Blender. These are shape keys. With the shape keys, you can make him smile, you can make him frown, you can make him look whatever you want to have. So why should we care about 3D? There's a couple of slides on this. First of all, the only thing that we can teach you here is how to be curious, how to really, really look into IT and look into the world as, what can I do here? What's cool? What's coming? What's new? And this 3D world enables you to experiment, and you can think of things, and you can think of, let's say you want to build like robots that nobody has done yet. Well, we have the tools. We have Blender, we have the printers, we have the Arduinos. You can do whatever you like. And if it's a good thing, then you can take it upscale and start manufacturing it. Arduino is, by the way, it's free. And you can buy those things. A basic Arduino is 24 euros, and the Arduino Mini is about 15 euros. So if you make something that works, well, it's easy to manufacture. So also you have to understand the sharing economies, like Thingiverse. Everything that I make for printing, I upload to Thingiverse. And every time I go there, there's people liking what I did, or people printing what I did, or people modifying what I did, because it's all open source. You can take any model, you can make anything out of it. You can even sell it if you want. 3D Hubs. This is in Helsinki as well. If you go to 3dhubs.net, you can see all the printers in Helsinki, and then if you want to print something, you can just click on the guy who's closest to you, and then it will tell you that it's 5 euros to start the machine, and then the material cost, which is usually 2 euros. So you can print anything in Helsinki, just like that. Send the file in STL and go get it 3 hours later. Pretty cool. So I would like to have the lab as a place where people just can hang out and talk to other people and start projects, and I could maybe issue challenges, and there will be prizes and whatever, so that we would actually have things going on. Because if there's no pressure, then there's space for innovation. Innovation doesn't happen like I go there and say innovate. It doesn't work like that. You have to have an environment where you can think about things and talk to people and find out things that everybody likes to do. And we already have the first firm, 3dcreatory.fi. Oliver Belfrage has a firm, and he just bought his third printer because he wasn't able to work with 2 anymore because of the work. He's making unique pieces for the construction industry, for example. Pretty nice. This is our lab at the moment. I am trying to find a new place for the lab. If I get 4 more printers, we won't fit in here, so I will have to find a new classroom. But we have the printers, Huey, Dewey, and Louie, and this is Donald. And then we have Blender workstations. Of course, every machine has Blender in it, of course. And here we have scanners. We have 2 different scanners. And then we have the Arduino robot area here with mechanical tools and soldering. Don't mind that. This is how the Spanish people always call people who go there on teacher exchange. I just have to put that there, so that you know. So I have already run one 3D theme group for thesis work. I had about 10 people who wanted to write their thesis on 3D. And there was one guy who looked at the printing methods, and there was another guy who wanted to compare scanner technologies. One of them took a small knight and passed it through the scanners into Blender and into Unity. So, and then there was another one who actually has the virtual headgear, and you can enter any building that a company has designed and go into any room and add furniture into it by just blinking your eye. That was one of the better theses, actually. So yeah, I'm really happy to see that I already have 10 people there, and of course happy to have even more. I'm going to start another group later in this period. These are our 3D scanners. This is actually using a high-definition webcam with a rotating table, and then taking about 40 pictures, and then we used Autodesk Remake to turn the object into a virtual object. And this one is an Arduino-based, where you have the Arduino here, you have 2 lasers, and then you have a stepper motor running this table. It's a robotized version, and it runs on its own. So this is what I can do. I can make 6,600 vertices from this doll, but then the first student who came in was able to pull out 120,000 vertices, and then the double laser can give you 1,400,000 vertices of the same doll. So that's a 500-time increase of vertices from what I was able to do. I was actually very happy to see that, because that's what I want. I want to make a proof of concept, and then I want people to come in and make it better. So the moral of the story is this: open source has the power you need. You don't have to buy anything. You can just get open source and start doing things with it. So it's not a question of what you can do, it's a question of what you want to do. And also we need to employ the initiative of the students, and I'm trying to get a thing called 3D project into the curriculum. And the 3D project would be 6 points of ECTS, and I don't know what people want to make. I just want to have the points, so that when they come back to me and they say that I want to make a game, for example, we can say, okay, that's a 3-point thing, or that's a 6-point thing. That's actually going to go through pretty soon, hopefully. So I want to get into a situation where people are already doing something in 3D, and I just acknowledge that, and I give them ACTS for what they do, because they do the work, and I just judge what they do, and I see how much time they spend and what they learned. And also, Unity imports Blender as such. So if you already know Unity, just learn Blender and you can start making game assets. There's a market for game assets, actually. You can sell those. So the Haaga-Helia 3D Club, then we already have 225 people the last time I looked, and we want to have live meetings, maybe once a week, once every 2 weeks or something. And I would like to have people who want to be Calidus tutors. Calidus is a system where you will be rewarded with ECTS when you teach people what you know. So if you do the Blender course well and you do the printing course well, I would hope to have a few people in the lab who would be able to teach other people how to print. And I would then be able to pass the printing course by display. They bring me what they printed, and I can see that they know how to do it, so I'll just pass them. And really, the tinkering in the lab is actually quite much fun. Once we get the projects going and everybody is doing something, it's going to be fun to see what people can make. So it's all about ideas, really. You just want to get the ideas flowing. So, coffee? Any questions? Yes? Mm. They have their own software most of the time. They also use a lot of 3D Max, 3D Studio Max. But when you went to see Peanuts, the movie, in the end titles it said snow scenes were rendered with Blender, because Blender makes better snow than 3D Studio Max. Render engines are a different item. If you compare, there's something that's not inside Blender as such. But now Pixar has released RenderMan for your own use. You can download RenderMan. And Blender has an add-on that enables you to use RenderMan for your own meshes, which means you'll get like professional quality renders, because RenderMan is the thing. So as soon as something comes out, 2 days later you go to blender.org and here's the plugin. So yeah, it's really cool. Anything else? Yep. Mm-hmm. Blender is, well, I always say that it's like the drug business. The first fix is free, and then you have to pay. No, basically, 3D is the same no matter what tool you use. So, and you can also actually, if you want to use Blender with a user interface that looks like 3D Studio Max, there is an add-on that makes you do that. But 3D Studio Max is the professional tool. That I have to say that in all fairness to Blender. 3D Studio Max is bigger, but there's nothing stopping you from working with Blender, starting your own company and doing Blender things. Because we can export OBJ files, we can export FBX, we can export anything. So it's easy to share files with other software. It's no big deal. Yeah, you can easily move on. Well, not, it's not, how should I put it? If you learn to fly business jets, if you fly like Boeings, and then you go into a company that actually flies Airbus, you will have to take a refresher course. That takes a couple of months. But if you fly Airbus 319 and then you take to Airbus 380, it's only a couple of days. So going from Blender to 3D Studio Max is a bigger thing than moving from Maya to 3D Studio Max, because they are both Autodesk products. But it's nothing that you couldn't do. It's definitely nothing that's too hard. It's just a way of understanding a slightly different logic in the workflow. No big deal. Do you have one? 3D movement tracking. Let's see if I know what you mean. Yes, you can if you want to, but I'll also show you something. This is Blender Guru is a guy who is Australian, but he lives in South Korea, and he makes all kinds of cool videos. Oh shoot! Now it should show. Is that what you mean? Motion tracking, there's two things actually. Motion tracking is like doing this, but then there's camera tracking. This is camera tracking. So the hole isn't there. The hole is Blender. But it's pretty realistic. Now, motion tracking basically merely means that you have to add something to your hand so that you can track that. But yeah, you can actually create the movement of the hand with Blender. Yes, you can do that. No, we don't have that, but it could be made. It could be done. That's a nice thesis, actually. Yeah. Yes. Basically, it gives you points in space. And you can then go between the points in space. If you know Python, Blender is written in C, C++, and Python. And you can write anything in Python, and Blender will then read it very easily. So yes, you can do all kinds of things. And that's how you do it. Any other questions? Yes? Well, once you understand how to use Blender, once you've taken the basic course, you can do this in 1 hour. You can shoot your own video, you can add your own augmented reality into it in 1 hour. Now, if somebody asks me about the boat thingy, how much did it take me to make the boat? Well, it took me about 150 hours, but I was teaching myself Blender as I went. I didn't know how to do that. I was learning on the way. If I studied it now, it would be a 15 to 20 hour project. Yes? I like watching Blender Guru tutorials. He makes the most tutorials, and he makes very easy tutorials. They're really easy to understand, and he explains why he does things. I don't like tutorials where just click here, click there, click there, click there, and hey presto, you have this. So he always explains what he's doing and why he's doing it. And oh, by the way, if we wanted to do this, then we will do this and this and this, and now that we're doing this, we go this way. So his tutorials are really high quality, because he really wants the users to understand and to learn. Any other questions? Well, yeah, that's how it's done, basically. Blender is tracking all those points. And once it has tracked all the points, it knows the location of the camera in relation to the ground. And after that, you can start adding things into the mesh, because the camera knows where it is, or the Blender knows where the camera is. So it's rather cool. When he first posted a 35-40 second piece saying, "This is my home street in South Korea. Oh my God, there's a huge hole in the ground." And it went viral for the while. South Koreans were like, "What is happening here?" So it's like, you shouldn't do that. It's terrible. Yes, but yes, sure. My vision for 3D printing at Haaga-Helia. Well, if I don't get the 500,000 plus machine, it's going to be 8 printers churning out interesting stuff for robot projects all the time. People taking their ideas and turning them into something that they need, that they want to have. I'll show you a couple of things here really quickly. It's actually here on my channel. How can I get there? My channel. So I've been doing bits and pieces. This is a two-way tiltable table. If you wanted to, for example, attach a webcam to that table, you can then tilt it that way and rotate it that way. Okay, this is the proof of concept thing. These are potentiometers here. I have to manipulate them by hand. But I already have written a small Python program that enables me to use arrows. Click on an arrow and the thing will point there, and click on the other arrow and it will turn there. Okay? Now, the next thing is that I just bought, this is the Arduino, I bought an Ethernet shield for that, so I can attach that thing into Ethernet. So I can then run it remotely. I can place it to summer house, wherever, and look around with the webcam from there. And I also bought a camera module for the Arduino, so I don't need the webcam anymore. So there's always like the next thing. And also my wife got a new phone, and I made her give me the old phone so I can use the Bluetooth. I have a Bluetooth module for the Arduino, so I can see how things go. And the bigger thing that I've made is a scanner for film. If you have 8mm film, you can actually scan the film using this. Sorry, just one way down. Here we go. So this machine has 8mm film running from here, going to the film gate, and then back to this other spool. There's a servo there, rotating that thing, and then there's a film gate. And every time this little switch is pressed, Arduino sends 5 volts to the old camera from 2002, and it grabs a picture. And in a 4-minute film, you have 3,880 frames. And this machine is able to grab them all. It takes about 4 hours to run, but I don't have to do anything. And then I have all the images, and I can take them into Blender and make them into an AVI file. Now, did I know exactly what I was doing when I started on this project? I had no idea how it's going to be made. So I made it piece by piece. I tested parts, I printed things, and then finally I came up with a thing that works, like so. So this is the fun part. The fun part is identifying what you need, then figuring out what do you have to have in order to get what you want, and then figuring out how to make those things one by one, and then putting it all together, and then having something like this that actually works. That's the cool part. And this is what I want to see. I want to see people with their own ideas, their own projects, so we can talk about these things and see how it goes. Any other questions? Well, in that case, I think it was there. Hope to see you on the Blender course and hope to see you in the lab once you have done the Blender course. Thanks.